If you have been following the semantic layer space recently, you have probably noticed something quite interesting. Snowflake and Databricks, two of the most powerful data platforms on the planet, have both decided that the semantic layer belongs inside their platform, not as a separate tool, not as an external layer, part of the warehouse itself. And honestly, on the surface, it sounds like the perfect solution. Your data is already there, right? So why adding another tool? Today, I'm going to show you exactly what Snowflake Semantic Views and Databricks Metric Views actually are, what they do well, where they genuinely shine, and where they hit a wall that most organizations don't discover until they are locked in. Let's get into it now. All right, first let's understand the architectural decision that both companies have made because it's actually a smart one, and I want to give credit where it's due. So both Snowflake and Databricks, they looked at the semantic layer problem and asked the same question. Why should your business logic live in a separate tool when your data already lives in our platform, right? So they decided to build a semantic layer inside their platform. Snowflake created semantic views, which are basically schema level objects stored directly in your Snowflake database or warehouse. You define your business metrics, your entities like customers, orders, the relationships between them, and then Snowflake's Cortex analysts can then use these definitions to answer natural language questions against your data. Databricks it took they took a similar philosophy, right? They are using unit catalog metric views, and the idea again is that you define your business metrics once at the data layer inside the unit catalog, and then it become reusable across dashboards, AI models, SQL queries, and data engineering tools. So first-class assets in the lake house. Think of it this way. So in essence, both platforms, they frame this as a define once, use everywhere. And within their own walls, their promise holds up reasonably well. The question actually is what happens at the edges of those walls? And that's where things get interesting. So let me be precise about what Snowflake semantic views are, because I think lots of the discussions around them is either too promotional or too dismissive. The reality is more nuanced. So here's what Snowflake got right. Semantic views let you define logical tables that map to business entities. You define facts like the row level measurements, like individual sales amounts, cost. You then define your dimensions, or in other words, the contextual attributes like region, product category, all these things. And finally, you define metrics, the aggregated KPIs that executives will actually care about. Things like total revenue, profit margin, percentage, all these things. These definitions live directly in your Snowflake schema alongside your data. So that proximity is genuinely valuable. No sync issues, no external system to maintain, no additional latency. Uh, Adding to this, like the integration with Cortex NLS, right? It's a compelling part of it as well. Once your semantic view is defined, business users they can ask questions in plain English, and Cortex analysts use those definitions to generate accurate SQL. The semantic layer becomes actually the grounding that makes AI actually reliable. You can share that semantic views as a first class objects through Snowflake Marketplace later and data sharing, meaning that you don't just share raw tables. You share the meaning behind them too. So that's genuinely interesting capability for data product teams. Now, here's where the wall actually appears. First, let's talk about scale. Snowflake's own documentation recommends no more than 50 to 100 columns across all tables in a semantic view for best performance, mainly because of context window limit in Cortex Analyst. Real enterprise semantic models often have hundreds of columns across dozens of entities. So that's not a deal breaker, right? It's a meaningful constraint to be aware of. Second, let's talk about portability. Snowflake semantic views, they live in Snowflake, of course. They govern Snowflake data. The moment your organization has data outside of Snowflake, let's say a legacy or on-premise database, a SaaS application, a second cloud warehouse like Databricks, for example, your semantic definition stop at the Snowflake boundary. So that's a major concern, right? Let's talk about a third concern. Let's talk about replication. As of the latest documentation, Snowflake semantic views cannot be used in replication. So for organizations with multiple regions, let's say you have a multi-region deployment or a disaster recovery requirement, that's a gap. You cannot solve that issue. And number four, building and maintaining Snowflake semantic views still requires a YAML, a SQL. So in other words, you will need data engineer skills, right, to alter them. Business analysts and data stewards, they don't have a seat at that table yet. That's the way it is. So genuinely strong within Snowflake, but constrained at the edges. Now let's have a look at Databricks. Same philosophical bet, right? Different execution, but similar approach. Databricks metric views live inside unit catalog, their governance and metadata layer. The core value proposition is identical to Snowflake. Define your metrics once at the data layer, make them reusable everywhere. What Databricks got right is the depth of governance integration because metric views are unit catalog objects. They inherit the full governance, let's say, stack, right? Lineage, permissions, certifications, usage insights, deprecation gaps or tags. So if you're already running unit catalog, the governance story is genuinely impressive. The SQL addressability is also a strength. Every metric view is fully queryable via standard SQL, which means your data engineers, analysts, and BI tools can all reach the same definitions through familiar interfaces. And the Power BI integration is real. Metric views can be consumed directly in Power BI, which matters a lot in enterprise environments where Microsoft is a dominant tool. Now, the limitations, let's talk about them, right? It needs to be said. And I want to be precise here because some of these are significant. So Databricks metric views, they work exclusively within Databricks. If your organization runs on multiple platforms, like the ones that I just mentioned, which sincerely most enterprises do, then your metrics are limited to that scope, right? To the Databricks scope. There's also a syntax constraint worth knowing. You must use the measure function when querying metric views. You can't treat them like normal tables in a standard SQL query. That creates friction for analysts who just want to write clean SQL. The join limitations are another real constraint. You can't arbitrarily join metric views to other tables in a single query. You have to use CTEs or define those tables directly inside metric view. For complex analytical queries, that adds complexity, to be fair. And like Snowflake, altering Databricks metrics views requires YAML or SQL. So business users, again, cannot participate in building or maintaining the semantic layer without proper data engineering support. So the pattern is consistent, right? Powerful inside a platform like Snowflake, but constrained beyond it. So here's the thing. I don't want to be unfair to Snowflake or Databricks. Those are great platforms, by the way. They both build genuinely useful semantic capabilities. The engineering is solid. The governance integration is real. But here's the fundamental problem, and I think it's worth saying it directly. Both companies, they built a semantic layer as a feature of their platform, not as an independent layer above it. Again, it's a feature. And when you build a semantic layer as a feature of a platform, it inherits all the constraints of that platform, right? It serves that platform's data pretty well. It speaks to that platform's tools in a solid way. It governs within that platform pretty easily, right? Now, ask yourself, what does a real enterprise data landscape actually look like? It looks like Snowflake and a legacy Oracle database or Postgres, right? It also looks like Databricks plus Salesforce, CSV files from the finance team. It's a more heterogeneous type of environment, right? This is what we normally see in enterprises. It also looks like Power BI as a business intelligence tool for one department, Tableau for another one, maybe a strategy, maybe Click. So it's a way more complex environment. It looks like the data has been accumulating for 20 years across systems that even nobody planned together. So it's complex. It's not that easy. We don't necessarily have everything inside either Snowflake or Databricks. When your semantic layer lives inside Snowflake or Databricks, it governs Snowflake data. It governs Databricks data when it's in Databricks, right? The moment you have both or either plus, anything else, your single source of truth is already fragmented across all platforms. In other words, you have solved the problem inside the platform, but you have recreated it at the enterprise level. And that's the wall you're hitting. That's not a good wall to hit, by the way. Well, this is where I want to introduce a different architectural conversation because I think it reframes the whole discussion, right? Strategy Mosaic doesn't compete with Snowflake or Databricks semantic layers. It actually occupies a fundamentally different position in the stack. Mosaic actually sits above these platforms, above Snowflake, above Databricks, above all of it. Let me show you what that means in practice. As you might know, Mosaic or strategy is multi-source by design. It connects to over 200 data sources, including Snowflake and Databricks, of course, Oracle's, Salesforce, Postgres, all those. So even legacy database or files, on-premise systems, cloud platforms, your semantic model spans all of them simultaneously in a single govern layer. One definition of revenue that covers your Snowflake data warehouse, your Salesforce CRM, and your on-premise ERP. All of them in just one place. Mosaic is also multi-BI tool natively. As you know, Mosaic supports JDBC, XMLA, DAX, REST, Python APIs. Power BI connects directly via DAX endpoints, the native Power BI language, right? That speaks directly to Power BI. Tableau connects through the universal semantic layer. Click, Excel, all of these tools, all of them connected, consuming the same governed definitions, which you cannot do with Databricks or Snowflake. With Mosaic, we invert that dependency. The semantic layer itself comes to the tool, not the other way around. And that's really important because most companies, they have different departments using all those different tools. And we want to facilitate things for these teams, right? Not to increase difficulty for them. Also remember that Mosaic presents the no-code modeling experience. This is a great differentiator because And I think that the data community normally undervalues this, right? Remember, Mosaic uses AI to analyze your data, to auto-create attributes, metrics, relationships, let users define metrics in plain English. It actually uses AI. Neither Snowflake or Databricks semantic layers, they offer this. Actually, they require data engineering expertise to alter, to create those YAML files or SQL. So that's not something that business analysts can actually participate. The business user experience is basically consumption only, right? And Mosaic is totally different in that matter. Let's include one more differentiator that actually speaks a lot about strategy, and that's the 30-year of semantic depth. So this isn't a minor point, right? Strategy has been building enterprise semantic layer technology since the early 1990s. They offer hierarchies, multi-form attributes, complex transformations, enterprise-grade governance. All of this has been refined through thousands of interactions with different customers, bigger ones, and it proves that the semantic layer offered by strategy is a powerful one, is a complete one, and that's something companies they should actually have in mind when choosing a proper semantic layer, at least in my view. So let's talk about the honest framing, right? If your organization runs exclusively on Snowflake and has no plans to expand beyond it, Snowflake Semantic View is a legitimate, simple choice, I would say. You get native integrations, zero additional tooling, a growing AI story with Cortex. Same for pure Databricks shop. It's the same thing, right? But the moment your data landscape extends beyond one platform, and frankly, most enterprise data landscapes they do, you need a semantic layer that lives above these platforms and not inside one of them. So to finalize, before you adopt the semantic layer, your warehouse platform built as a feature of their platform, ask yourself one question. Is my data state going to stay inside one platform forever? I doubt it. Not just today, not just this year, I mean forever. If that's the case, and I doubt it to be fair, well, the answer is yes, keep it simple, stay native. That's fair. But if the answer is no, or even if the answer is a maybe, you need a semantic layer that is architecturally independent of the platform itself, right? It needs to sit above the platform because a semantic layer that lives inside your warehouse is only as universal as that data warehouse itself. And calling something a single source of truth when it only covers part of your data isn't a solution at all. It's just a feature. So the difference between a feature and a foundational architecture actually really matters, especially when you are building something that you expect to last, which is something that, of course, we want to do, right? We don't want to do things that will be needing to replace in a few months or a year. So think about it seriously. All right, so that was it for this comparison here. Snowflake, Semantic Views, Databricks, Metric Views, Strategy Mosaic. What do you think about them, right? What is the best solution for your enterprise data ecosystem as a semantic layer? I would like to hear your thoughts. So as I normally say, feel free to share, to subscribe to the channel. It's my pleasure to have you guys here viewing this content, and I'm really looking forward to seeing you all in my next corner.